Hello, this is Mike Lively, and today we're on Knowledge Space Hunter, and we're going to talk about dimensional reduction right here. And you may be wondering, what is the heck is dimensional reduction? Well, when you're working in multidimensional spaces, dimensional reduction can sometimes be your best friend. I mean, it's hard to, in a sense, navigate a 5D space. So what we're going to do in this particular article is show you how to reduce down to 3D and navigate in a 3D cube as opposed to 5D. All this comes from my book, Chapter 1, and let me bring up the draft write-up. And in the first part of the section, I just talk about poker itself. So if you're new to poker, it might be frustrating figuring out what hands are better than others. But actually, the winning hands are the hands that have the lowest probabilities of occurring. And in the book, I talk a lot about probability space, and I explain all the mathematical theory behind it. We won't go through that right now. But let's go right to the image that we want to discuss. So what we're actually doing is we're actually taking a deck of cards and putting it on a single axis. So that's one card. So from along this single axis line, you can make one event choice, and that's one card. And then what you have here is you just have 5 card studs, so you need 5 axes, so poker's played in 5 dimensions. And it turns out that any hand is the intersection, okay, of those 5 axes in multidimensional space. So that's how you do it in 5D. Now, how many possible hands are there? Well, including non-realistic hands, it's 52 times 52 times 52, or that equals, let me see if I got the number here somewhere, about 400 million possible hands. Here it is right here. So what that means is that 5-dimensional space, that you have that many points. So imagine that you're holding a hand. It's the 3 of hearts, 7 of spades, 10 of clubs, jack of clubs, and 5 of diamonds. Then that is 1 point out of 380 million plus that you could have chosen from. So in this space, there's 380 million plus points. Now that could actually be converted to a decimal number using base 52. So we have a basis of 52, that's our axis, and so that immediately just brings us to a base 52. So that means each number using base 52 is actually a decimal number. And so once you have that decimal number, you can actually convert it to a different basis. So we're going to go from a 5D basis to a 3D basis with different coordinate systems. So coming down just a little bit lower, so we're going to change this 5D search space right here to a 3D search cube. So as I search along that cube, it turns out that all possible points can be contained in that cube. So if you multiply the dimensions of this cube, 832 by 676 times 676, you'll actually get that 300 plus million number. So that means each pixel in this search cube, including Z, is a point or a deck of card hand. And we're going to show that. We've written that program. We'll show that program to you. And so to do the conversion, you want to first, since this part of the book shows you how to convert to that decimal number using base 52, so go review your base numbers. And then once you have that done, here's the formula, in a sense, taking that base number and getting that same base number using X, Y, and Z. So it's actually pretty simple. Just a few code hints I want to make. The algorithm is in the blog. Here's the algorithm for basically finding your card. So once you have the base number, so you're going to search in 3D space. You find each pixel represents a base number. Once you have that base number, you want to convert it back to your base 52 so you can choose the card that you want. I'm suggesting to make your code faster, go ahead and multiply the exponents that you'll be dividing on in the algorithm. If you multiply those exponents out, then in a sense you'll save your time, all this computational time, as far as doing these exponentials. So just multiply them out. And here's the code for the conversion, and it's extremely simple. It just follows the algorithm that's given in the blog post. So you make sure you take a look at that blog post. Let's go back and take a look at that real quick. What is that blog entry? You can find this blog at kshunter.wordpress.com. It's a very lonely blog right now. There's only been about 56 hits, but as we move forward with the technology, I'm assuming there'll be a lot more. Of course, as an author, you write a book and you wonder if it's going to go or not, but this is a beautiful book. I'm very excited about writing it. So just go to my blog, kshunter.wordpress.com, and what you want to do is scroll down on this article here, Dimensional Reduction, and come down here to the actual link, and you click on that link, and up will come the program. And so here's the program right here, and what happens is as you roll along here in this search box, you can see the X, Y, Z are appearing over here on the left-hand side, and the cards are changing as I roll. Now if I click and hold, I actually go back in Z. Isn't that cool? So now I can move in X, Y, and Z. And what you notice, I've actually coded the cards to music as well. So each deck of card has its own musical sound. Isn't that pretty cool? Okay, good. Move forward. And so there's actually about 40 million points here that we're actually searching through just by rolling our mouse back and forth. And that's the program right there. And you can download this program from my Google Code. So if you come along here, just a link below it is the actual link to get it. Just click on that. And that'll take you right to my Google Code and actually download it for you. So good luck on the program. And let's just take a look at the Flex program real quick before we let go of it. The Flex program is really pretty cool. And you know, guys, I love Flex. And I do a lot of writing. And I actually wrote this in Flash Builder. And just one thing about this code, I actually used, I believe, the next build. So I actually used build 14288. So you want to go review my video on basically how to upgrade to a higher level Flash or a new SDK. So here's the code right here. Starts off with the import statements. Then after the import statements, I have all my various decorations. And then one thing I want to do is pretty much this. I have those sounds that are playing. So I'm going to declare those sounds, and they're all coming from my embed statement. And after I do that, I have a few intro sounds I don't hear here, but later on I do. I have those static constants that I'm using that are multiplied out, so I don't have to use that exponent over and over again. And let's move on. Here's my bindable private A, B, C, and D, and I'm actually using those right here so I can pretty much change that, and that's all changed dynamically in the code, so whenever I put something in the new image, it goes there. And then here's the codes which transform, I guess, the sound to the music, so you need that as well. So go back and review that video I did on my piano synthesizer. And at that point, here's the algorithm I showed earlier, converting my decimal number in 3D space to back to 5D, and then actually from that getting the source image that you actually want to put into each individual card. So that gives me the card index. And that, once again, comes from the embed images of my embed class that I talked about in earlier videos. And at that point, here's my mouse move that basically does all this. Tells me where my mouse is, and if I want to move an X and Y or an X and Z, it does that for me. And finally, let's see what we got here. And finally, here's my handler for playing the music, and you can see in each instance I have a sound channel that I'm loading into a sound by, basically a card sound, and I'm playing it. And that's pretty much all there was to the program. Let's look at it one more time. Okay, and we'll play it. So back to the book's blog, and there it is. You're searching in 5-dimensional space. Now in the next program, we're going to show how to bring this up to 20-dimensional space. What do you think about that? And after that, we're going to show you how to navigate in multidimensional geometry and go from one point that you find in knowledge space to another just by a simple translation. And after that, we're going to start actually taking that curve and stretching it out in a Bezier curve in multidimensional space, and then zipping around these different points in multidimension and finding new knowledge. Thanks a lot for listening. This was Mike Lively.